Word problems, love them. Okay, there is a formula that I'm gonna crank out right here, and you're gonna be like, man, that makes no sense. But then once you see it and you work with it a little bit, it'll make a little more sense. So x minus standard less than or equal to the tolerance. Okay, what does tolerance mean in this mathematical context? Tolerance is going to be how much wiggle room you have. So let's read the problem. The weight of each fountain pen must be 10 grams. Okay, it's got to be 10 grams. But are they all going to be exactly 10 grams? No. Some of them are going to be a little bit more than 10 grams. Some of them are going to be a little bit less. That's what the tolerance means. So that's what I call the wiggle room. So some fountain pens are going to be 10.05 grams. Some of them are going to be 10 minus 0.05 grams, so 9.95 grams. But they're all about 10 grams. So to represent that, like between two numbers, like you've seen in this lesson, we write it as an absolute value. So pens that are not within the tolerated weight must be recycled. The dump heap for you. Write an inequality that represents the situation and solve and graph the inequality on a number line. So this formula that I just wrote is going to apply to all problems in this kind of context where that is the lamest highlighting you ever saw, wasn't it? Wow, yay, thank you for that highlighting, Mr. Reader. So, I forgot what I was saying now. All of the problems that deal with a tolerance are going to involve basically that. So let's just write them down, and these will not be that bad. Pens that are not within the tolerated weight must be recycled. Write the inequality that represents the situation. Solve and graph the inequality on a number line. So let's do it. So I'm going to have, well, x minus the standard. What's the standard? 10. The standard weight of a fountain pen is 10. So x minus 10. And the tolerance is 0.05, so less than or equal to 0.05. So that was the inequality that represents the situation, but now we're going to solve it and graph it. And if we solved it by hand, which we have done, if we solved it by hand, then we would have this situation here, 0.05, or we would eventually have to subtract 0.05. So we're going to basically sandwich this in between positive 0.05 and negative 0.05. And we would add 10 to all three sides of this inequality. So we're going to add 10 to you, add 10 to you, add 10 to you. Running out of room, going to bring it up here. So x less than or equal to, and then sandwich it in between. So 0.05 plus 10, so 10.05. You can do that in your head. Like you can kind of read the problem and do that in your head. So 10 plus 0.05, 10 minus 0.05, and that's what this is. So that would be 9.95. And then graph the inequality on a number line. Let's use a number line. I will use a number line. Now, if you want to get technical, I probably shouldn't have an arrow on both ends of it because, you can't have a fountain pen that weighs an infinite amount or a negative infinity. But if we're going to truly put it on a number line, we would do that. So 9.95, 10.05, and then we'll graph it the good old-fashioned way. So circle here, and these are the numbers between them. So here's the deal. You're not going to have a fountain pen that weighs 11 grams, right? So you're not going to shade 11. You're going to be shading things that, you notice my mistake too, don't you? There's a terrible mistake on here. I'll fix it in a second. You're going to be shading things in between 10.05 and positive 9.95. I don't know what is up with your fountain pen that weighs negative 9.95 grams. Like your fountain pen keeps floating up to the ceiling. Come back, I'm trying to take notes. Okay, well, the tolerance does include, so we will fill in these circles, and that is the number line graph that represents the weight of a fountain pen. It could be anywhere from this many grams to that many grams. Okay, you've seen the first problem. Let's go a little bit faster on the other ones. Write an absolute value of inequality for the temperature that was recorded to be as low as 65 and as high as 87 degrees on a certain day. This one's different. No. Okay, actually, this one starts here, and we're going to have to work our way backwards. They didn't tell us to graph it, so we're not going to. So the temperature, call it T if you want to. I think I will. T for temperature is between, including 65 on the low end, 87 on the high end. And so now we're going to have to kind of work our way backwards. So in a minute, we're going to have this, the temperature minus something less than or equal to something. So what was the standard? Now, standard may not be the right word for this, but what is the number that is in the middle. The middle. Let me rephrase that. It's the average. So the number that is exactly in the middle between 9.95 and 10.05 is 10. So what's the number that is exactly in between 65 and 87? So add 65 and 87, divide by 2, or you can just kind of count and do it in your head because you're smart. But it's 76. So 76 is exactly in the middle of 65 and 87. If you need to graph it, you can. I said I wouldn't, so I'm not. I almost picked up a pen and graphed it. But if you were, you said you weren't going to graph it, sir. 65, 87, it's not a full graph. Work with me here. 76 is exactly in the middle. So now the question really is, how far is that? How far is that? Like that, what's that distance there? And a lot of this can happen in your head, right? I mean, this is going to be basic math. Grab a calculator if you need to. And I won't shame you for that, but you got this. So what's that distance? Well, it's 11. So the tolerance of the temperature for this particular day is simply 11. And if this is truly the middle, that better be 11 and that better be 11. So 11, and that's it. Okay. Next two problems are almost exactly like the first two, and so we're just going to go through those very quickly. Length of a railroad beam is 10 feet long. That's the standard, so x minus 10. Looks a lot like the first problem. Has a tolerance of 0.25 inches. Write an inequality that represents the situation. Okay, I have messed up already, and here's the problem with this one. That's feet, that's inches. Oh no, what am I going to do? I'm going to fix it. I don't want 10 feet. I want inches. So instead of 10 feet, I'm going to be like 10 feet equals 10 times 12, 120 inches. 10 feet times 12 inches. I want to put that in context. 10 feet equals 10 times 12. No, it doesn't. 10 feet times 12 inches, so 120 inches. So I'm looking at this actual equation here. I'm bothered that this, I shouldn't have this part because it doesn't really look mathematically correct. I mean, it works out in terms of physics. And I'm going to take the word feet out. There. That works. Anyway, I was just bothered that I had 10 feet equals 10 feet times something else. That just didn't jive with me. Okay, sorry, back on track. 120. We're going to just convert everything to inches, which is what we just did. 120 and then 0.25 inches, so 0.25. All they wanted us to do was write the inequality. Done. You had to find the standard. You had to find the tolerance. They gave you the tolerance. They gave you the standard, but you had to do a little work. And then your teacher kind of wrote something that looked weird and unmathematical. Okay. Similar situation here. We have the weight of a 40-pound bag of fertilizer. It varies as much as 4 ounces. Okay, we're dealing with pounds and ounces, so we need to convert. W is the weight of the bag, so W minus something less than or equal to. I like to go for the shortest, feet and inches are shorter, or the lightest, pounds and ounces is lighter. So I like to go for the lighter, the shorter, the smaller, basically. And so 4 is that. So now the question is, 40 pounds is how many ounces? And, well, now things get tricky. So I have 40 pounds, wrong color, 40 pounds, and there are 16 ounces in a pound. So 40 times 16 ounces is going to give me 640 ounces. Write an absolute value for the weight of inequality. Let W be the weight of the bag. 640. They didn't want us to solve and graph these. You could if you wanted to, but chose not to.